All right, this is gonna get really repetitive, but we're gonna be doing this is stoichiometry involving mass calculations. So we're given a reaction, and for all four of these, we wanna know how many moles of NO2 form, and we're gonna say we're given this reactant, and it's gonna completely react. We have enough of everything else. So the important thing to remember is before you can change substances, you have to have a balanced equation and you have to be in moles. So we're already in moles, so that's good. That's a good start. So once we're in moles, we can change substances using the balanced equation. So 2 moles of N2O5, and then you go to whatever it tells you. NO2, there's 4 moles of NO2. And this just says moles of NO2, so we can stop there. All right. If you set it up, the calculator does the hard work. Don't reduce any fractions. Just let that happen. So you should get 5. All right. Same thing, but a different amount. We're already in moles. Once we're in moles, go ahead and change substances. Okay. So sometimes the numbers aren't quite as pretty. That's normal. So here we get 13.6. All right, looking at this one, we're given grams. We cannot go to the equation being in grams, so we need to convert to moles. So let's do a molar mass. You can use your periodic table. 14.01 for nitrogen, 16 for oxygen. I have my periodic table up here, out of reach of the camera, but again, I know it takes a little bit longer, but I need you to write down what your substance is. I don't want to see moles and moles on the test. If you want to do shorthand on your own, that's fine, but I need to know that you are correctly switching out substances. Times 4 divided by 108.02 divided by 2. So here we get 0.281. Last one of these, 2.87 kilograms. We don't need kilograms, we need to be in moles. However, in order to get to moles, we need to be in grams. So hopefully you remember that 1 kilogram is 1,000 grams. And say molar mass. Now we're in moles, so we can convert. And we get a big number, 53.14, which you would expect from kilograms. Okay, here, not a lot of room to write, but we're gonna make it work. All right, we want to know the mass of the product. Now, all these are synthesis reactions, so there's only one product. And we're given 3.67 grams of whatever's underlined, and we're to assume there's enough of the other one. All right, so let's start this out. So we're going from 3.67 grams of barium, and we want to go to grams of barium chloride. So let's go to the periodic table and get a molar mass. 137.33. Now that we're in moles, we can make the conversion Do not skip this, and do not try to tell me it's a wasted step. It is not. Just get in the habit, because you have to change substances through the equation. Now we need molar mass. And give me a second. That's going to be 208.23. 23. Yeah, you're going to get tired of writing compounds when you do that, but that's all right. All right, so now let me scoot this up so you can see everything. All right. All right, 5.56. And this one, same starting amount, different reactant, different product. So that's kind of another point of this exercise. Calcium oxide. We need a molar mass. Calcium 40.08 and 16. Okay. One mole. Now we know 1 mole CaO, 1 mole CaCO3. Now we need to go back to grams, because that's what it's asking us to find. We want mass in grams of the product. All right, calcium is 40.08, carbon, 3 oxygens. Calcium carbonate is also known as Tums. It is also known as limestone, also known as hard water, or what makes water hard. You'll do stuff with that in lab. Divided by 56.08. All right, 6.5. Not BA. Ooh. Let's need some more caffeine. Okay. Now, Mg. Okay, we're given 3.67 grams of magnesium. Periodic table says magnesium is 24.3. If you say, this is so repetitive, Dr. B, I know, I'm glad you think so. 2 moles equals 2 moles MgO. This is also a reaction you'll be using in lab, or at least hopefully you'll be using it with the, depending on how the lab schedule goes. Hopefully you'll still get to do that. And we know 1 mole of MgO is 24.3 plus 16, 40.3. All right, let the calculator work. .09. Last one of these. 3.67 grams. In this case, our reactant is aluminum. On the periodic table, 26.98 gives us grams, gives us 1 mole. Here, 4 moles of aluminum gives us 2 moles of aluminum oxide. And now we need aluminum oxide's molar mass. So 26.98 times 2 plus 3 oxygens. 101.96. So just multiply across the top, divide across the bottom, and you get 6.93. Now, for these next ones,